Kinetic energy is the particle theory explains the properties of the different states of matter. There are three main types of state: solid, liquid, and gas. They all have different amount of energy. Particles of solid are close together and they cannot move around because particles are stick together in a fixed state, which is no space in there. However, liquid particles can move around each other inside their shape container, and gas particles can move in every direction and quickly. The process of change in state is like the circle from liquid to solid by freezing, from solid to liquid by melting, from liquid to gas by boiling, and from gas to liquid by condensing. There are two ways that heat can transfer: evaporation and condensation. Evaporation can involve from liquid change to gas, while condensation can involve from gas change to liquid. In evaporation, particles can have different energies and some of them will have enough energy escape from liquid to gas. The evaporation happens when liquid cooling down. Example of evaporation is when people playing sport and they are sweating to cooling down inside.
However, in condensation, particles do not have enough energy to remain from separate particles, and it happens when the gas is cooling down as particles come closer and bond together. Example of condensation is foggy in a cold day. Factors that affect the evaporation and condensation are when the surface of liquid increases and when air is moving over the surface of liquid.
Increased temperature of gas is increased the pressure, as the pressure is directly proportional to absolute temperature, and double temperature produced with double pressure. For example, if gas heated, the particle will move faster and kinetic energy increase, the particle wall will be harder. The formula of constant is constant equal P divided by T, where P stands for pressure and T stands for temperature.
Physical property of a solid body relates to application of heat energy. It defined as thermal properties, and the four important thermal properties are heat capacity, thermal expansion, thermal conductivity, and thermal stresses. Heat capacity is represented the amount of energy needed to raise the temperature of a substance. This is the formula of heat capacity, where C is capacity, Q is the energy required to produce, T is the temperature change. And as you can see that the unit of heat capacity is JK. Thermal expansion defined as the change in the dimensions of the material per unit length. This is the formula of the thermal expansions, where T0 and Tf are the initial and final temperatures, unit is K. Lf and L0 are initial and final dimensions of the material. The symbol like E is the strength. The unit of the thermal expansion is the symbol of temperature -1. And this is the thermal expansion value for metal, the polymer and ceramics. They have different value. Energy can be transferred by conduction, convection, and radiation.
Convection is the heat that can be transferred to one place to another. It occurs in liquid and gas, which known as fluid. Convection occurs when particles with a lot of heat energy in a liquid charge. The metal ions are packed close together and vibrate continually. When we heat a piece of metal, the hotter the metal, the more kinetic the energy this vibrate have. This kinetic energy is transferred from the hot part to the cooler part of the metal by free electrons. Since metals are good conductor of heat, gas and liquid are usually bad conductor. Convection. Convection is the heat can be transferred to one place to another. It occurs in liquid and gas, which known as fluid. Convection occurs when particles with a lot of heat energy in a liquid or gas move and take place of particles with less heat energy. The liquid or gas in hot area is less dense than the liquid or gas in cold area. So it rises into the cold area. The dense cold liquid or gas fall into the warm area. Convection current can be seen in lava lamp. The wax inside the lamp warm up, become less dense than liquid and so rise. When it rises, it cools and becoming dense again, so it sinks. This same effect can be seen by putting a crystal of potassium permanganate in a beaker of water and gently heating. Convection is seen on a much bigger scale in our river and ocean current.
Heat can be transferred by infrared radiation. Unlike conduction and convection, which need particles, infrared radiation is a type of electromagnetic radiation that involves waves. Because no particles are involved, radiation can even work through the vacuum of space. This is why we can still feel the heat of the sun even though it is 150 million km away from the Earth. Some surfaces are better than the others at reflecting and absorbing radiation. As we can see that rough surfaces are good absorbers and emitters of the radiation. However, shiny surfaces are good absorbers and emitters, but they are good at reflector of the radiation. If two objects made from the same material have identical volume, a thin flat objects will radiate heat energy faster than fat objects.
Consequence of energy transfer, conduction, convection, and radiation are constantly happening in our everyday environment. When we heat up pot and pan, the thermal energy is transferred through the conduction. When heating up water, the heat is applied from below, so it creates a convection current which heats up the whole body water. Radiation enters greenhouse through the glass and the heat is absorbed and trapped to maintain the temperature.